A Hilbert space, named after David Hilbert, is a concept in functional analysis, a branch of mathematics that deals with vector spaces and operators acting upon them. It's a generalization of the notion of Euclidean space, and provides the mathematical foundation of quantum mechanics and many other fields. In simple terms, a Hilbert space is a vector space equipped with an inner product, an operation that allows lengths and angles to be defined. Furthermore, it is also complete, meaning that a sequence of points in the space can converge to a limit that is still within the space. Vector spaces and inner products. A vector space is a set of objects, called vectors, that can be added together and multiplied by scalars, real or complex numbers. Examples of vector spaces include the set of all real numbers, the set of all 2D or 3D vectors, and the set of all continuous functions. An inner product on a vector space is a way of multiplying vectors together to get a scalar. In a real vector space, the inner product of two vectors is a real number, while in a complex vector space, it can be a complex number. The inner product allows us to define the length or norm of a vector, and the angle between two vectors. Completeness. A metric space is said to be complete if every Cauchy sequence of points in the space converges to a limit that is still within the space. A Cauchy sequence is a sequence of points that get arbitrarily close to each other as the sequence progresses. A Hilbert space is a complete inner product space. This means that not only does it have an inner product that allows us to define lengths and angles, but it also has the property that every Cauchy sequence of points in the space converges to a limit within the space. Applications of Hilbert spaces. Hilbert spaces are used in many areas of mathematics and physics. One of the most important applications is in quantum mechanics, where the state of a quantum system is represented by a vector in a Hilbert space. The inner product in this space is used to calculate probabilities of different outcomes in quantum measurements. Hilbert spaces are also used in functional analysis, the theory of partial differential equations, and in the mathematical formulation of Fourier series and transforms, among other areas. In conclusion, a Hilbert space is a key concept in functional analysis and quantum mechanics. It generalizes the notion of Euclidean space to infinite dimensions, and provides a rigorous mathematical framework for many areas of mathematics and physics.